NPM hack, billions of downloads affected. 19 NPM packages compromised in major supply chain attack. 18 popular packages hacked, rigged to steal crypto. This is literally the biggest supply chain hack ever. What the heck is going on? This seems like a really big deal. Over 2 billion downloads of a package that was malicious trying to steal crypto. This seems like a really big deal, right? Well, it is, but not necessarily for the reasons you might think. If you're worried about tons of money that's been stolen, it looks like less than 22 cents was actually taken. And if you're worried that you have malicious code on your machine, it is somewhat likely that at some point you might have touched one of these packages, but as long as you do a new npm install or npm update, you'll be good to go because all of these malicious packages were removed from npm in under 8 hours. All of that said, this is really, really scary, and the path that leads to something like this happening is way more worth looking into than the details of what came out as a result of this hack. So if you're here because you want to see how much money these hackers made, go watch any of the other videos. There's lots of good commentary about what the results of this hack were, but I want to go the other direction. How did we get here? What can we do to prevent it? What's the actual risk profile of things like this? And most importantly, how do we make sure that our applications are safe going forward? I'm honestly hyped to break this all down with you guys. That said, I'm not a hacker. I'm not stealing 15 cents from people via NPM, so we got to pay some bills. Quick word from today's sponsor, and then we'll dive in. AI agents are really cool, but they don't really fit well on modern infrastructure. You can throw them on a server, but now you're executing arbitrary code. Good luck sandboxing it. Or you can throw it on a serverless instance, and now you're paying a bunch of time as the code waits for the AI agent to spit out the next token. That's not fun either. What if we had infrastructure that was built from the ground up for agents? Thankfully, today's sponsor is exactly that. Daytona is the best way to run AI code. Be it an agent that's spending a lot of time waiting on generations or AI-generated code directly where you're letting it write some TypeScript or Python to go execute in the cloud. If you're trying to build more powerful agents, the infrastructure they run on is essential, and Daytona understands that deeply. This is how easy it is to spin up an actual sandbox environment using Daytona. Sandbox equals await daytona.create. You give it an object that is describing the environment. You then can execute commands in it. Await sandbox.process.execute command, echo hello world, and you can then just log the result. Yes, really. You can set up a VM and send commands to it with literally 5 lines of code. Not only do these VMs have full file systems where you can write and create files, great if you're trying to build an AI code agent in the cloud, you can actually access them through the SDK almost the exact same way you would with Node directly. They even have a Git plugin in their SDK, so you can make calls to Git commands like adding files or pulling or pushing changes. If you're trying to build your own cloud vibe coder, this is one of the most essential ways to do it, especially when you include the LSP plugin. Yes, it can actually process the language server protocol for you as just part of the SDK. You can set up an environment for whatever you want, but you can also use the built-in stuff. If you want to just execute some TypeScript code, pass it. Sandbox.process.code run, and now it will run that code and give you a response. You can control what the VM has and doesn't have access to. I've found that AI gets a lot smarter when you let it write some code to go solve the problem. Now you can build that into your own services with literally 3 lines of code. This all works because their infra is serverless, stateful, and long running. By the way, $200 of free compute when you sign up. That's a pretty hard deal to beat. If it seems too good to be true, you should go try it out yourself. Check them out now at soydev.link/Daytona. So super quick timeline. Again, there are lots of other creators you can go to if you want to go in depth on the details of the actual hack. We want to focus more on the ecosystem, why this can happen, and what will be the concerns we have going forward. First, phishing email sent to big OSS NPM maintainer. The maintainer that the email was sent to was Quix, Josh Junin. He's a good faith, hardworking open source maintainer that has run and built and contributed to so many different things in the open source JavaScript world, and also works on NPM stuff for a lot of these projects. It is one of the people who helps publish them, which means he has the rights on NPM to publish updates to packages. So a phishing email was sent to him. The phishing email was suggesting that you do a 2-factor authentication reset. It's a really common one, and the domain was npmjs.help. This is a pattern I'm seeing more and more, in particular with those .help domains. They're being used for a lot of these types of things. I recently got a fun email. This email is from alerts@contentreport-x.com, but I do believe somewhere in here, I thought they used a help at. I guess I was wrong about that. This is a DMCA notification for the T3 Chat Twitter account. We've received notification that a post you shared on X may contain material that's not fully licensed or otherwise restricted. This content may not be fully compliant with X's terms of service and community guidelines, particularly regarding intellectual property. You get the idea. Obviously, this is a copywritten image where I am violating copyright on the T3 chat account that I don't even run. This is just to legal@t3.chat, which isn't even a real email. We just have a catch-all. And there's a submit appeal button, which goes to cdn.ampproject.org. I wonder where that comes from. What happened here is a generated email. There is some bot that scrapes Twitter accounts looking for ones that look like companies that have a domain in their little website box. They find the most recent media post. They generate this fake DMCA notification email. They send it to legal at whatever that website is, hoping that somebody there clicks this button, fills out the info, and now your Twitter account is compromised. You might think that this only happens to dumb people. I was about to screenshot this and send it to the team saying, LOL, look what they're trying to DMCA. I know better than to click links in email, and I also am very, very familiar with phishing. I've been running things with lots of users that phishing scammers want access to for most of my life at this point. So I've been through it with these, and even then, I almost was got, not by it, I would never have clicked the link, but I did very momentarily believe this was a real DMCA notification. It's surprisingly easy to do this, both because most email clients obfuscate the email address things came from a little too aggressively, but more importantly, because making an email template that looks good is so hard to do that real companies don't. This looks like a more legit email than the ones I actually get from Twitter. We're at the point now where phishing emails are better looking and more real looking than actual emails from providers. I still get plain text emails with broken hyperlinks on official Gmail comms for a bunch of stuff, from Google directly. You never know when you get an email from Google if it's phishing or not. I've had official things that they were obviously phishing, and I've had things that were obviously phishing that looked way more realistic. So don't go at any one person for getting phished. Do your best to check every link before you click it and to check the sent from address for every email before you do anything. Email verification is an absolute mess, and you need to do due diligence before you ever click on or sign into anything. This is also one of the things I really like 1Password for, because 1Password as an extension won't sign into credits for one site on a different site. So if you have credentials for x.com and you try to sign into help-x.help or something, it will give you a warning that it is a different site and it won't let you do it by default. So thankfully, tools like that help, but it's still not enough. You still need Tufa, you still need other things. So in the defense of Quix, there have been many people that are even smarter and more successful than either him nor I that have been hit by these types of things. The Linus Media Group for LTT, you guys all know Linus, they have been hit multiple times with things like this simply because it's so common. When you get all of these emails and you have to worry about your accounts being taken down, if you don't respond to a DMCA notice fast enough, you don't think as rationally, you go do it, and then the thing's down. They sent the phishing email, they got access to his NPM account, and then they added this malicious JavaScript to every package he had access to with a patch version. Clearly automated, they were able to just publish all of those almost instantaneously. There's a lot of speculation that this was a targeted attack, that they specifically went after this guy because they knew he had access to a ton of packages and wanted to hit him specifically. The nature of how automated step 3 was suggests otherwise. My honest guess is they have a bot that hunts through NPM looking for packages that are popular, checks the GitHub, checks who's contributing, tries to find an email address through Git commits and whatnot, and then spams them with generated emails like this in hopes one of them clicks it. And as soon as they get a notification on their side, they have credentials to an NPM account, they immediately go in and run their script that pushes all these malicious updates. Almost certain that is what happened here. Not the targeting of Quix specifically, but Quix being the victim of a general spear phishing campaign that uses NPM data and GitHub to try and find, target, and spam the right people who might have a package that they can hack. And also, to Quix's credit, he has been in every repo for everything that was affected, giving detailed updates and status reports on what went wrong, why it happened, what the timelines are to fix it, and what you can do to protect yourself. So if they're working this hard and we're all going so crazy about this, the impact must have been really bad, right? We'll get there. We need to talk a little bit about NPM itself, though. If somehow you're not familiar with NPM directly, it's the Node Package Manager, which is particularly funny, in particular the Node part, because the vast majority of things that are installed from NPM are not actually used for Node. Think about the packages that you install from NPM. Obviously, you have backend things like Express, but you also have things like TypeScript, which is more of a compiler and an LSP and a system of tools to turn these files that browsers don't understand into files that browsers do understand. You also have tools like Babel, Webpack, etc., that are compilers that take all the JavaScript in your codebase, bundle it, and then make a thing that users can access. But you also have things like React, the thing that most of us use for building our applications nowadays. That comes from NPM. You also have things like React Query, which is a library I use heavily for a lot of my applications. I'm going to break these down into 3 types. We have backend Node packages. These will be things like Express, TRPC, the server side, Hano.js, tools like that are meant to be run in Node on a backend. You then have tooling packages. This is things like Babel, TypeScript, etc. There is actually a 4th category, which we'll do in a sec, because we want to talk about front-end packages first. Front-end packages are things that you install via NPM, but you're not shipping the NPM package directly to the user. Funny enough, you're using tools like Babel and Webpack to take all of the packages that your front-end needs and pull those all in and bundle them into that 1 or 2 JS files that gets sent to the client that users actually use and have access to. There is an interesting growing 4th category, which I'll call applications packages. This is stuff like Claude Code. You could also argue this is stuff like Bun, which fits somewhere between the tooling packages and the CLIs and applications because it's a thing that you run and execute. There are all of these different types of packages. That said, when most people think of a package on NPM, they're thinking of this. They are thinking of a front-end package. Sometimes they talk about these. Sometimes we talk about these too, but they're not talked about in terms of packages. They're talked about in terms of tools. So the 2 things people usually are thinking of and are referring to when they talk about NPM packages are these 2 parts. So why is this all relevant? We need to talk about the nature of the hack. The way the hack worked was actually pretty clever. It looked for strings that roughly matched the shape of a cryptocurrency address for various different cryptos. And if it saw one, it would swap it out with one of the hundreds that they had hard-coded in that looked similar enough, like it had a start and an end that were vaguely similar. So if they swapped it out, you were less likely to notice the address change before hitting send. Honestly, pretty clever, except for the fact that it only affects front-end packages that are bundled into your application. So the only way this could have affected you is if you were on a website that used an affected package that had since done the update, installed that package, and then had it bundled into the website into the new version of the site shipped with that affected package. That is a surprisingly large number of things that have to happen in a short 8-hour window. I think it's actually 6 hours in order for this to affect you. And that has to happen on a website that is a crypto site that has plain text crypto addresses, which to be frank, most do, that it can then swap out the addresses for and receive these transactions. So what packages were actually affected by this hack? What's the list of relevant packages? We have ANSI styles, which as far as I know is for terminal stuff. ANSI styles, very much terminal color package. You have debug, which I don't even know what it does, but I mostly know it as a thing that packages have as a dependency for server-side things. You have chalk, which is for applying colors in the CLI. Supports color, which as far as I know is for checking what colors are supported by the platform you're on in the terminal. Yeah, okay, so we are terminal again. Strip ANSI, also terminal. ANSI regex. Theoretically, you could use other places. That's going to be used in the terminal. Wrap ANSI, we know what that's for. Color convert. You get the idea. The first thing we've hit here that I would actually expect to exist on your front end might be is array-ish. What does that even do? The terms of an object can be used as an array. This could be used in a lot of different places hypothetically. It is quite popular. Here's one that's a little scary then. Slice ANSI, same deal. You get the idea. The vast majority of these things are for use in CLIs. Even supports hyperlinks. That's does the terminal support having a link. So of the 19 packages that were affected, one could reasonably have been included on the front end. The vast majority of the packages that were hit here don't work with the hack that they had built, which once again confirms my hypothesis that Quix wasn't specifically targeted. If this was a plan to go after the 19 packages that this one particular dude had access to, they would have built malicious code that focused on this part, the backend node packages. Things that would have had pre-install scripts that affect your system. Things that, when executed, touch your file system, write files, and do malicious things on your computer. Things that might screw with your DNS and your methods of using the internet, packet sniffing, keyloggers, all those types of things, because they would have access to your computer, not to your DOM. And to be frank, getting access to somebody's computer is almost always a valuable thing. And if they had planned accordingly and went after the backend node packages with a hack specific to the backend node packages, they could have done significantly more damage. But because these hackers are not very good at their jobs and didn't have a hack ready to go for backend focused node packages or tooling focused ones in a similar regard, they were embedding a front end hack that requires certain things like fetch and DOM node access to work. Not only did that mean the hack didn't work for 18 of the 19 packages, it also resulted in people noticing the hack much earlier because they would see an error saying fetch does not exist because they put fetch calls and other similar things for front end in the obfuscated code, which wouldn't be there and not in the environment at all for a lot of backend projects. If you're on an older version of Node, you have no fetch that you can call. So if you saw a patch for a package that is meant to run on backend and you're now getting an error that it can't access fetch, you're going to be curious why you're getting that error. You look into it, you see this weird new thing. All of a sudden, you understand what happened. It's not surprising it got found so much quicker than the Geotan stuff for that reason, because they were using a front-end hack on back-end projects. Also of note is that the same hack hit DuckDB recently, which, as you can guess, is primarily a server-side package. They do have a WASM binding. You would imagine that that's got to be for the browser, right? No, this is so that you can run it on Cloudflare. So DuckDB was affected and was patched reasonably quickly, but it was hit with the exact same malicious code to interfere with cryptocoin transactions, which means that there was probably 0 victims of this one because it was on the back end. So it's particularly funny that the code only works for front-end projects that are bundled and have this code getting snuck in so that it can run on a browser, but all of the things they've successfully pwned have been back-end engineers using back-end packages through NPM. This is just luck to an extent because, again, they're not doing a very good job targeting. They're not going after front-end developers. They're going after back-end package maintainers, and they're adding front-end specific code to their packages. I really hope they don't use this as advice to do this better, but they were so close to actually doing something big here, and by sheer incompetence, 100% failed to do such. That said, another hacker can now see how effective the strategy is and absolutely destroy the entirety of the trust in the ecosystem if we don't get better about avoiding these types of things. So what can we do to avoid this? Point 1, which is pretty obvious, check where your emails came from and where they're linking to. The problem with this strategy is that it has a single point of failure, which is the developer who is responsible for your packages. And now with a lot of these packages, there are lots of developers responsible, and many projects have hundreds, if not thousands of packages involved in their production development. Thankfully, despite all of those facts, this hack didn't become a problem because of the thousands of packages that people have installed on their stuff, the affected packages were here where the code couldn't execute. So lots of projects have a package in them that was affected by this, but very few of the projects were actually affected due to the nature of where those packages went. But if they were going to the right section of their packages, this could have been really, really bad and would have affected a lot of people. So checking your emails helps, but it doesn't help a lot when you have all of these different packages from all of these different places with all of these different contributors, any one of which could be compromised and now ruin the integrity of your application. So how do we work on that? Here's the interesting and important point 2. Make sure you only update packages when you know what the update has. This one's honestly kind of hard to do in practice. Like, you're not going to go check every dot update of every subdependency. But when Dependabot shows up with a PR saying bump all of these things by clicking the merge button, a lot of people do that. And that is not necessarily a good thing. Ideally, you should at least check a change log of where these changes came from. And in that process, you probably would have seen all of the work that, what was the name of the dev? Oh, what's his name? Oxy, I think, was doing to make it clear what had went wrong here. But there's one particular thing we can do that makes this way less likely to happen. Use less packages. This is the key piece. And if you look at Twitter right now, or you watched other videos by other people who have talked about this, a lot of folks are really focused on this bit. There are far too many packages that far too many of us use that are less than 200 lines of code that are doing simple things. Yes, there are the is-evens of the world I don't think that is the relevant part here, though. The thing that is much more common, if we again go to the list of all of the packages that were affected, a lot of these packages are convenience things that are annoying to write, like color string to get the right string for an ANSI color, or color name, which turns those ANSI strings into English names so you can go back and forth more easily, or strip ANSI, which strips a bunch of ANSI stuff, or ANSI regex, etc., is arayish, getting 73.8 million downloads per week. Most of these packages are probably less than 30 lines of code. They're effectively an annoying to write object with key values to map from one thing to another, and then a basic function that is exported for you to access it. These being packages is nice in the sense of like separation of concerns, clear, concise, and reusable. Like the isArrayish package is something that this developer probably wrote in 3 different projects, was tired of it, so he made it a package so that he could just have one thing to reference for all of his projects. And isArrayish hasn't been updated in 7 years, which is actually a pretty good sign this package is, for the most part, safe. But why do we have all of these in our ecosystem? Why is it so common that for a Rust project we have hundreds of packages and for a JavaScript one we sometimes have thousands? Why do we get here? A combination of us installing packages that solve problems we have, and then those installing packages that solve problems they have, those install packages that solve problems they have, we end up with this crazy graph of dependency hell. And you do not know anywhere near all of those packages if you're building a modern web or even a backend in Rust style app. So how can we avoid this? We have various different theories from various different people that I've been collecting from Twitter. We will start with Bun's take. Bun has fast built-in alternatives for popular NPM packages like strip ANSI, which has bun.stripansi, string with, same with bun, escape HTML, exec A, better SQLite 3. Fewer dependencies is good for supply chain security. This is true. If you are able to reduce the supply chain risk by having fewer packages, in particular, fewer of these really simple packages, that's a good thing. That said, I fundamentally disagree with the idea that this should be built as part of the frameworks or tools that we're using. Introducing more complexity, more pieces, more stuff to something like Bun or something like Go or some standard library might have long-term annoyances that result in things like if it turns out Bun isn't actually faster than Node for something you're doing, you can't move because you're calling all of these Bun APIs. It's a lock-in method. Or in a language like Go, if their web server has weird edge cases that are annoying you, you basically have to work around them because nobody's putting the work in to make a good alternative because everyone just uses the built-in. So by building solutions in, you're increasing the maintenance burden for the maintainers, you're increasing lock-in for users who might want to switch to other things that have different implementations, you are massively bloating your documentation in the surface area that your system, language, infra, framework, whatever covers, and you are reducing the likelihood that better solutions come out from the community. A common example of this is like browser standards. A lot of people have said that Chrome should ship with React because every site uses it. React's like 80 kilobytes. If every site shipped with it, we would all be stuck using the same version of React, and a new framework would now be more expensive because React is 0 kilobytes, it's in the browser, everything else is 80 to 200. You're being irresponsible using React, it prevents future iteration, and it makes it more likely somebody's on an outdated or broken version of React on any given website. It doesn't make sense to build in a lot of different things, especially weird integrations with other tools like SQLite. I really don't love the idea of Bun itself, like when you npm install Bun as a global, that it includes code for SQLite in that binary. Because now when I take this binary and I ship it up to a server to run the code, even if I'm not using SQLite, that is now included in my bundle. I don't love the idea of including everything in these ways. Just how I like to think and do things myself. This is the point Jared made that I just don't agree with. When there's a less than 100 line of code NPM package that gets tens of millions of monthly downloads, that's a hint it should perhaps be part of the runtime. So many of those packages are people who aren't good at their jobs, and I do not agree that we should make lives of the maintainers of the languages harder because people don't know how to write the 3 lines of code for is even or is odd. Ugh. The other take I'm seeing in this regard is that we should be checking in our node modules into Git. By doing this, you would guarantee that the specific version of the package and the code that was in that package at that time is now inside of your GitHub repo. Guaranteed. And it also increases the cost of adding more dependencies, which is a good thing. There are languages that do this. Languages like Go are aggressive about this. All of your dependencies are bundled as code files in the project. He also said that most code libraries should probably be zero dependency, even if you have to reinvent the wheel a bit. I'm going to do my favorite thing and drop my spicy in-between take that both covers all of these and pisses people off. This is how I recommend using fewer packages. So the option as presented by Bun was that these should all be built into the runtime. For the reasons I stated earlier, I do not agree. The obvious solution that we're all thinking is write the solution yourself. And I understand why people are skeptical of this. I understand why many devs don't want to figure out how to do weird ANSI color conversion, and instead of figuring it out, they find this package and just install that instead. Because somebody smarter than me solved the problem, we should just use their solution. There are some problems that are so complex that the package you need to solve it is inherently going to be really annoying. Things like TSUp, for example, that takes your TypeScript files and turns them into a single executable you can use as a package. TSUp is simple in what it does and relatively small, but it's incredibly complex, and good luck, have fun trying to write your own alternative, something like that. But once you've gotten good enough at writing code, you start to get a good gut feel for what is and isn't complex, and you can install packages by trusted sources for the complex things, hope they're not using a bunch of subdependencies that are small and stupid, and then in your own work, when it's something smaller or more easily writable, you can write it yourself. So solution 1, write the solution yourself. Fine. So now we have solution 2, which kind of touches on Jared's comment around less than 100 line of code NPM packages. If the package is small enough, I think it's reasonable to just copy the source into your code base directly. I've done this a couple of times in T3 chat. There's a package that was made by some Vercel folks to make it easier to turn a Redis pub sub into an HTTP stream and vice versa that we use for our resumable stream stuff. It's a really useful package with some things I'm not necessarily in love with their implementation. So I go to the GitHub, I grab the code from the package, I paste it in my code base, because in this case, it is a small, simple thing. It's a single file with 80 lines of code. I fix the things I don't like. It now sits in my code base and does exactly what we need to on a package that barely gets updates. If you're going to do this one, I have a couple things I would recommend. Make sure the package is actually small. So not just checking the lines of code, but making sure it's not calling native binaries or things like that, because it might have 8 lines of JS, but then call a native binding that is huge. So do a brief look and see how reasonably big or small the package is. And also take a look at the update throughput. If the package has been getting updates every couple days for years now, you probably shouldn't do this. But if the package, like is arrayish, is 9 lines of code and has not received an update for 7 years, you should just copy the source into your code base. But on the topic of copy-paste, the industry has made significant advancements in our ability as developers to copy-paste at the speed of light. Now we get into everyone's favorite topic that I talk too much about, AI. Specifically, those small packages that less competent devs weren't capable of writing and more competent devs didn't feel like writing. Those types of packages are ones that are often made into these small one-off tools and use cases. A lot of these sub 100 line of code packages aren't there because the thing is really hard to write. They're there because it's annoying to write. And AI is incredible at writing annoying code. A hill that I am very willing to die on now, I brought this up in a recent vibe coding video, is the idea that if you dislike AI code slop, you have to kind of give up your right to talk shit on things like is even. These are solutions to each other. If you don't like people writing code they don't understand, you should like the fact they can install a package instead. If you don't like devs having all of these different packages, you should like the fact that tools like Cursor, Claude Code, Windsurf, and more make it easier for developers to get the code they don't know how to write, copy paste it into their code base, or just let the AI do it for them and can move on with their day. The only way you can hate both of these is if you are choosing to hate the tools instead of hating the fact that a lot of developers just suck. One of my favorite thought exercises is the average rule. Imagine in your head a perfectly average developer. Just think about all the devs you've known in your life. What's the middle? The average dev. A totally normal average dev that fails a bunch of interviews but gets one good chance, can do leak code medium problems with enough time, and doesn't know what's going on in any major ecosystem, like your usual average dev. 2 spicy things you have to digest. Thing 1 is that if you're in this community, your bar for average is too high. Your average dev that you're thinking of right now is better than the real average dev. But thing 2, the part that's even harder to accept, is that the average dev is the median dev, the middle dev, which means half of developers are worse than they are. So now that you have the average in your head, accept the fact that half of the people in this industry are worse than them. And even then, there are way more developers who are learning how to code that aren't really in the industry. The tale of capability is really, really, really rough here. The average dev has no idea what the fuck they are doing. I'm not saying the AI does. The AI is not sentient. It is an autocomplete machine. But if there is 9 lines of code that have been shipped around the world 80 billion times, there's a good chance the autocomplete engine can autocomplete that specific code. AI takes those incompetent people that previously would have installed one of those obnoxious packages. It makes it way easier for them to not have to do that. It also makes it easier for somebody like me to, instead of writing the code or going to find the package, seeing how they do it and copy paste it, just type in my editor, -- function to turn ANSI colors into plain text. You know what? Let's try this quickly. I am going to go grab one of these official hacked packages, determines if an object can be used like an array. This one hasn't actually been updated for 7 years. Let's say you need this in your code base. Here is the snitch bitch code base. Let's try to get this functionality for ourselves. Export function is array-ish. Cool. Now we have a function that might work for a lot of our cases, but we want to know specifically if an object can be iterated instead. So I'm actually going to delete this, do a comment, checks if an object can be iterated over like an array. Press enter, wait. Okay, array.isArray value or type of value equals object. That doesn't seem quite right. However, Command K, make this work like isArray-ish. There we go. Now we have this function. Let's look at the official source and see how close we got. If no object or type of object is a string, return false. Object instance of array or array is array object or object length greater than 0 or object splice instance of function. So get on property descriptor. Descriptor name is not equal to string. This got most of it. That was just using GPT 4.1, by the way, after using autocomplete up until then. Depending on what your use case is for this, many of those implementations along the way might have worked and been even less code, depending on what your actual goal was. And if it didn't, you could have said to the chat on the left here, I need to know if this object can be parsed through and iterated on like an array, make a function that checks it, and it probably would have handled it fine. So a package like this that you might have reached for that has a bunch of checks that you don't actually need won't be installed. Instead, you just have the code in your code base. I have a lot of these types of functions that I write in almost every code base that I'm working on, especially in the web, just things that I reuse over and over again, like a fetcher, where we fetch the URL. If the response isn't okay, we create a new error and we throw it so that I have a version of fetch that can throw. Makes it easier to deal with the success and failure cases when you're trying to do a lot of random work over fetch. Those types of wrappers I have in almost every code base I touch. So having autocomplete capable of generating them or a agentic tool on the left sidebar that can get me what I want without even having to leave my editor and go find it in the web is an ergonomic win that solves the problem. There's a thing I think a lot about from our favorite person in gaming, Gabe Newell. A while back, Gabe Newell dropped a legendary quote that has haunted many industries since. Piracy is primarily a service problem, not a pricing problem. It would be easier for many people, a lot of the time, to go pirate a game than it was to pay for it in an easy, simple, reliable way. If you wanted to go find the game online to pay for and play, at the time, there were many different websites that may or may not have it with their own weird DRM and restrictions. I had times where I bought a game on a disc and I would install the cracked.exe so that I didn't need the disc to play it because the checks it would do with the disc and with the internet to make sure I owned the game were just so annoying. And honestly, since Steam came out, I've pretty much entirely stopped even looking at piracy stuff. The only time I ever go to any tracker is when I want to see something early that leaked. I didn't say that. I obviously talking about leaks, the plant, and piracy, the fact that we love pirates here so much are. You get the idea, though. Gabe Newell's quote was that piracy was a result of bad services primarily, and piracy has gone down significantly since things like Spotify existed for music, Steam and Netflix existed for games and video, etc. So why am I bringing this up here? Why do you think is even exists? Some amount of this is incompetence. Some amount of this is inconvenience. Some amount of this is memes and Google indexing and all of those things. I would make the argument that most of these types of tools and packages exist because of an ergonomic problem. The language is missing a feature in its core library, in its standard library. You'll have to write that code more. If there's a common thing you're mapping between, like object to array and vice versa, you're going to need to go find code to do that. And if your editor and your language don't make it easy enough to write and do this code, you're going to go to your browser and look it up in Google. And once you look it up on Google, the likelihood that you find the package instead of the code is very high. So the ergonomic problem is that the language, the developer, the tool, whatever, make this problem perceived as annoying or hard to solve, or you have to write the code yourself, which is annoying. Some ergonomic failure about the language, the tooling, etc., leads to you leaving your editor and going to the browser, looking for a solution. And when you do that, you find a package as the solution that you then install into your code base and you get back to work. So once the ergonomics of the tools, the language, the capabilities of the developer, etc., hit a certain threshold of, I just call it failure or incompetence, you leave and you go do it with a package instead. So how can we improve the ergonomics of the experience we have as developers where we run into this problem and eventually leave to the browser to go find a solution? You solve it by keeping them from ever having to leave the editor regardless of their capability. If you can keep a dev in the editor when they run into this problem, even if you don't like the fact they don't know how to write the code, and I don't either, I make it a huge point around all the stuff I talk about, that if you're using these AI dev tools to write code you do not understand, you should stop using them and go get better at coding first. Use these tools to write code you understand but don't feel like writing. Or in this case, to rewrite a package or a feature you don't feel like going to the browser to find the package name for, see what the status is, see how it's updated, all of that. So to the people who are upset about these types of things, both the small packages that everyone is using and the surface area for exploits and concerns, please accept the fact that AI does actually solve the paths that lead to this in the first place. It's one of the big benefits of these new AI tools. They are so ergonomic that they are easier than the browser, and they're easier than finding a package. Similar to how Steam is easier than pirating a game, that is how we solve the problem. We don't solve it by getting really angry at people. We don't solve it with laws suing people for pirating games or installing packages they shouldn't install. We don't solve it by bitching on Twitter or baking better standard libraries for languages people don't actually use. The solution to this problem is to solve the ergonomics that lead to somebody going to grab a package in the first place. But ergonomics has two sides to it. There is the inconvenience that leads to you going to do the thing, but then there's the inconvenience of going and doing the thing. Leaving your editor for the browser is an inconvenience. And here is where my spiciest take comes in. An actual solution to the small package problem. The problem is that installing a package is more ergonomic than writing the code. AI helps reduce the ergonomic cost of getting the code in your code base, but that's only one side of it. We need to increase the ergonomic cost of going out to the browser and installing this NPM package. This is touched on by Jamin with his suggestion here, where he says that we should be committing our packages and our node modules because it makes the cost of adding dependencies higher, which is probably a good thing. I agree with the goal here of it should be more expensive to add deps. Not all deps, but certain ones. And here's where my crazy suggestion comes in. Someone should add a lint rule that checks how big a package is, and if it is small enough, throws an error and forces you to add it to the code base instead. Duh. Seems like a really easy fix for a lot of the things we're concerned about here. You could even have it give you a prompt in the error message that says, hey, you installed this package that's actually really simple. You have two options. You can go write this exclude comment somewhere that we check before we throw this hard error, or you can copy paste this specific prompt into your AI editor that you're probably using. Like, let's be real, if you're installing is even, you're using some agentic coding solution. So give me the prompt, I can copy paste into my text editor that will let me automatically both remove the package so it's gone and copy paste the code that I need into the editor and into my project so I don't need a package to do the thing. It would be very easy to have this lint rule check how many lines of code are in the package and potentially even check how recently the package was updated. Although chat is making some very valid points here that I do want to address. This would only be for direct dependencies though, right? Not some dependency 12 levels down. Yes, absolutely would be the case. The risk here is for when you bump the packages. I would be surprised if any higher level deps did a package bump and a publish that resulted in the types of exploits we're concerned about here. All of that said, a culture shift to everyone using a lint rule like this, in particular, package maintainers using a rule like this, would be a pretty big net positive for the entirety of the web dev ecosystem, because that change would almost instantaneously result in many of those packages having way fewer subdeps that have problems like this. So yes, whatever the lowest point in the chain is that is installing all of these subdeps, that should be the piece where this lint rule is actively enforced. But I see no reason that someone couldn't make this and apply it to lots of different projects at all of these different levels, and maybe even throw a warning if you install a package that has a lot of dependencies that doesn't use this lint rule. There's a huge opportunity for general linting and auditing tools to prevent these types of things, but the key here is to both make it easier to do the right thing, which is have the code in your code base, and harder to do the wrong thing, which is installing a dependency so you don't have the simple code in your code base. So these tools should make it easier to go write that code or provide that code or automatically generate that code, but also harder to put yourself in a position that will cause this all to happen in the first place. And now for the inevitable thing I know will happen with me dropping these takes. I do not like to say AI can solve every problem. I am not that type at all. I like AI for the things it can solve, but I am very much, nowadays especially, kind of in the middle of the AI thing. I find it way more useful than a lot of the anti-AI developer shitposters that haven't shipped anything in years, but I find it much less useful than the people who were DevRels before that couldn't get a real job at engineering that now just shill AI all day because they never knew how to code in the first place. I am somewhere between the two, where there's a lot of work I don't feel like doing, that AI makes it easier, but just the fact that I believe that, and I see a use case for it here, is enough that people will write off the stake entirely of course, Theo thinks that safety can be solved with AI, or of course, Theo thinks more packages and more lint rules will magically solve the problem. Yes, because I live in this fucking ecosystem, unlike almost everybody else who's commentating on this. The vast majority of the commentary I saw, none of which was included here by me, because I don't want to include this type of commentary, has come from people that are not part of this ecosystem, that do not understand the developers who cause these things, who do not understand the paths that lead to them, saying this happens because JavaScript is bad. We should fix JavaScript. No, we should fix the tooling that leads to developers doing these types of things. Hopefully, my take on this is actually useful here. I'm sorry that I didn't do a 5-minute video doing a quick Fireship style overview of a thing that Fireship already covered. I wanted to talk about the actual things that led to this, the dynamics of NPM that prevented this from being risky, and most importantly, what we can actually do as developers to prevent things like this going forward. I hope this was helpful. Let me know if it wasn't. And until next time, please do not install a package to check if a number is even. That's 2. It's even. I promise.